Welcome back, students. In this video, let us solve the questions PYQs from theory of equations. Given alpha, beta, gamma are the roots of the given equation. We have to form a quadratic equation with integer coefficients whose roots are alpha plus beta plus gamma plus delta and alpha, beta, gamma, delta. The given equation is of degree 4. So first let us write the given equation. The equation is 2x power 4 plus 5x cubed minus 7x squared plus 8 is equal to 0. Let us divide the equation by 2 and here we get x power 4 plus 5 by 2 x cubed minus 7 by 2 x squared plus 4 is equal to 0. Now the equation is of the form sum a x power 4 plus b x cubed minus which is equal to sigma alpha which is equal to minus b by a. Sigma 2 will be is equal to sigma of alpha beta sum of product of the root which is equal to c by a, and sigma 3 will be is equal to sigma alpha beta gamma which is equal to minus d by a, and sigma 4 will be is equal to product sum alpha beta gamma and delta. Since the equation is of degree 4, we have product alpha, beta, gamma and delta. Now here sigma 1, that is alpha plus beta plus gamma plus delta will be. Now product alpha, beta, gamma, delta will be is equal to 4. Now we want the quadratic polynomial equation with roots. The polynomial quadratic minus 5 by 2 and 4 is given by x minus of minus 5 by 2, that is x plus 5 by 2 into x minus 4 is equal to 0, which gives us this is nothing but equal to 2x squared, and hence the equation with the from the question we can write the equation with the integer coefficients whose roots are, that is the quadratic equation is the quadratic equation is 2x squared minus 3x plus 20 is equal to 0. Taking the x squared minus 5x plus 6 is equal to 0. So it can be written as x minus 3 into x minus 2 is equal to 0, or x is equal to 3, 2. So let us take the roots to be alpha and beta. Therefore, let alpha be is equal to 3 and beta is equal to 2. Now, therefore, alpha square minus beta square will be is equal to 3 square minus 2 square, which is equal to 9 minus 4 is equal to 5. Suppose when we take alpha is equal to 2, beta is equal to 3, then alpha square minus beta square becomes is equal to 2 square minus 3 square. So that is equal to 4 minus 9, which is equal to minus 5. Therefore, in general, we say alpha square minus beta square will be is equal to plus or minus 5. Find the polynomial equation of minimum degree with rational coefficient having 2 minus root 3 as a root. Therefore, let us first write what is given. Given 1 root is equal to 2 minus root 3. So, let the other root will be is equal to 2 plus root 3. Now we are asked to form a polynomial equation of minimum degree. Minimum degree will be of degree 2 and that is a quadratic equation. For that, let us find what is the sum of the root. Sum of the root will be is equal to 2 minus root 3 plus 2 plus root 3, which gives us which is equal to 4. Now finding the product of the root, product of root will be is equal to 2 plus root 3 into 2 minus root 3, which is equal to 2 square a plus b into a minus b, a square minus b square. So 2 square which gives us 4 minus root 3 square which is 3 which is equal to 1. Now we have found the sum and the product of the roots. Therefore, the minimum polynomial equation of minimum degree, that is the quadratic equation, can be written as x square minus sum of the root into x plus product of the root is equal to 0. That is x square minus sum of the root is 4 minus 4x plus product of the root is 1. So plus 1 is equal to 0 is the required equation, polynomial equation of minimum degree. The next question, we have seen already a question like this. given x square plus 5x plus 6 is equal to 0, we are asked to show that alpha square plus beta square is equal to 13. So given here the equation is x square plus 5x plus 6 is equal to 0. So the factors are x plus 3 into x plus 2 is equal to 0, or x is equal to minus 3 comma minus 2. Let alpha and beta be the roots of the given equation, where alpha is equal to minus 3 and beta is equal to minus 2. Therefore, alpha square plus beta square gives us minus 3 the whole square plus minus 2 the whole square, which is equal to 9 plus 4, which is equal to 13. Hence, prove that alpha square plus beta square is equal to 13. The next question, if P is real, discuss the nature of the root of the given equation. Always when we want to find the nature of the root, we know the discriminant delta to find the nature of the root. We use delta will be is equal to discriminant b square minus 4ac. And using this b square minus 4ac, we say that the roots are real or equal. When delta is less than 0, we say that the roots are imaginary. When delta is equal to 0, we say that the roots are equal. And delta is greater than 0, we say the given equation has a distinct real roots. Now coming to our question is given that the equation is 4x squared plus 4px plus p plus q, p plus 2 is equal to 0. This p plus 2 is a constant here. We consider it as a constant. Now coming to this, will be is equal to b square minus 4ac, which is equal to 4p the whole square, 16p square minus 4 into a is 4 and c is p plus 2. Simplifying the given equation, this is equal to 16p square minus 16p minus 32, or this can be written as 16 into p plus 1 into p plus 2, p minus 2. Now finding delta here, delta becomes less than 0. If equating these values to 0, we get here p is equal to minus 1 and 2. So this delta becomes less than 0 if p lies between minus 1 and 2 here. Substitute the value for p is equal to 0, we get a c between minus 1 and 2. We get 16 into 0 plus 1 into 0 minus 2, which gives us 16 into 1 into minus 2 is minus 2 minus 32, which is negative. So delta is less than 0 if p lies between minus 1 and 2, and delta becomes equal to 0 if we take the value for p, equating this term to 0. This term to 0, we get p is equal to minus 1 and p is equal to 2. Next, delta value is greater than 0 if the value of p is less than minus 1 or p is greater than 2. Thus, the conclusion we can write for this problem, three roots if minus 1 is less than p less than 2. First point. Second point, it has equal real roots if p is equal to minus 1 and p is equal to 2. And the given polynomial has distinct real roots if minus infinity less than p less than minus 1 and p is greater than 2 can be written as p2 less than p less than infinity. This implies that p is less than minus 1 and p is greater than 2. Next question, obtain the condition for the given equation if the roots are in AP. So given the roots are in AP, so let us take the roots to be are in AP. Therefore, let the roots be alpha minus d, alpha and alpha plus d. Now, applying the Vitas formula, sum of the root will give us minus alpha minus d minus p divided by 1, or this will be, which implies 3 alpha is equal to minus p, and we get alpha is equal to minus p by 3. Next, we know that alpha is one of the root of the given equation. Therefore, substitute alpha in the given equation. we get minus p by 3 the whole cube plus p into minus p by 3 the whole square plus q into minus p by 3 plus r is equal to 0. So this becomes minus p cube divided by 27 plus minus p whole square becomes plus p square into p becomes p cube divided by 3 square is 9 minus pq divided by 3 plus r is equal to 0, or the given equation can be rewritten as this is 27 is the LCM minus p cube plus 3p cube minus 9pq plus 27r is equal to 0. Or adding these two terms, it becomes 2p cube minus 9pq plus 27r is equal to 0, or it can be written as, which implies 2p cube plus 27r is equal to 9pq. The side of a cubic box are increased by 1, 2 and 3 units respectively to form a cuboid. Volume is increased by 52 cubic units. Show that the volume of the cuboid is 60 cubic units. So here let us take the side of the cube to be x. Next, therefore, volume of the cube will be x into x will be is equal to x cube cubic units. Now this cube, when increased by 1, 2 and 3 units, it forms a cuboid. So the volume of a cuboid will be x plus 1, x plus 2, x plus 3. Length, breadth and height are increased by 1, 2 and 3. This is equal to, and this volume of the cuboid, we know it is x plus 1, x plus 2, x plus 3. From the given question, volume is increased by 52. So volume of the cube is increased by 52. Now simplifying the given equation, multiplying the first two brackets, we get x squared plus 2x plus x plus becomes plus 3x plus 2 into x plus 3 is equal to x cube plus 52. Now multiplying these two brackets, this gives us x cube plus 3x squared plus 3x squared plus 9x plus 2x plus 6. Bringing these terms to the left, minus x cube minus 52 is equal to 0. So here x cube goes off, cancel 3x squared gives us 6x squared, 9x and 2x gives us 11x square 11x. 52 minus 52 plus 6 gives us minus 46 is equal to 0. Now this can be further simplified by taking 11x, we can split as minus 12 and 23. So this factors of the given equation can be written as x minus 2 into 6x plus 23 is equal to 0. Now x cannot be 23 minus 23 by 6. Therefore, we take x is equal to 2. If x is equal to 2, we are asked to find the volume of the cuboid. Volume of the cube becomes equal to x cube. Volume of the cube, that is 2 cube, which is equal to 8 cubic units. Similarly, volume of cuboid becomes, volume of the cuboid will be is equal to x cube 8 plus 52, which is equal to 60 units, cubic units. Next question, solve the equation minus 3 is equal to 0 given 1 is a root. Therefore, one factor of the given equation can be written as, one root is given to be x is equal to 1. So we divide this x minus 1 is a factor of the given equation. We can write that x minus 1 is a factor of the given polynomial minus 3. Now this 2x cube minus 9x squared plus 10x minus 3 can be written as, this is equivalent to x minus 1 into another factor. So we are going to find this factor. Now to find this factor, we use the synthetic division method. Write the coefficients 2, minus 9, 10, and minus 3. We know that 1 is the root of the given equation. Therefore, divide by 1 here. 2 into 1 is 2, minus 7. So here minus 7. 10 minus 7 is 3. 3 into 1 is 3. So here 3 minus 3 is 0. So this factor can be written as 2x squared minus 7x plus 3. So I write the other factor here as 2x squared minus 7x plus 3. Now we have to find the factors of this polynomial. Now to find the factors, now we know that this can be written as, therefore this is x minus 1 into product taking 2x squared minus 7x plus 3, product is 6, and we get minus 7. It can be written as 2x squared minus 6x minus x plus 3, or this is 2x into x minus 3 minus 1 into x minus 3. So the factors are 2x minus 1 into x minus 3. So I can write here the given equation is equivalent to, which implies x minus 1 into 2x minus 1 into x minus 3 is equal to 0, which gives us x is equal to 1 comma 1 by 2 comma 3. These are the roots of the given equation. Show that the polynomial equation has at least 6 imaginary roots. So we are going to use the Descartes fix. Now let us see the change of sign from plus to minus. Here plus to minus 1 sign change, minus to plus 1 sign change. So number of sign change will be is equal to 2. Number of sign change for p of x is equal to 2, then more than 2. So it has 2 positive roots. The given equation has 2 positive roots. Now let us see what is p of minus x. P of minus x, substitute the value of x as minus x. So here the power is odd, so it becomes minus 9x power 9 minus 2x power 5. Power is even, minus becomes plus, so this doesn't change. Minus x power 4 minus 7x squared plus 2 is equal to 0. Let us see the sign change here. The sign change, we have only one sign change here. So number of sign change in p of minus x will be is equal to 1. Number of sign change is 1, and therefore it has only one negative root. Therefore, number of real roots will be, number of real roots is equal to positive root is 2 plus negative root is 1, and therefore the real number of real roots will be is equal to 3. Now we are asked to find the number of imaginary roots. So the imaginary roots will be total number of roots for the given equation. It is of degree 9, so it has 9 roots minus 3 real roots. So the remaining imaginary root will be, there are 6 imaginary roots for the given equation. Show that it has at least 6 imaginary roots. We have shown it has 6 imaginary roots. The next question, alpha, beta are the roots of the given equation. Construct an equation whose roots are alpha square and beta square. So first let us write what is the given equation, that is 2x squared minus 7x plus 13 is equal to 0. The roots of the given equation, we know that sum of the roots. Let us find what is sum of the roots if the roots are alpha and beta. So let alpha, beta be the roots of the given equation. Therefore, sum of the roots will be is equal to minus b by a, that is 7 by 2, and product of the root will be is equal to, product of the roots will be is equal to c by a, which is equal to 13 by 2. Now we are asked to construct a quadratic equation with roots alpha square and beta square. So sum of the root in the sense this is equal to alpha plus beta, and this is equal to alpha beta. Now we want to find what is alpha square plus beta square. Sum of the roots. If alpha square and beta square are the roots of the equation to be formed, alpha square plus beta square will be is equal to alpha plus beta the whole square minus 2 alpha beta, which is equal to 7 by 2 the whole square minus 2 into 13 by 2. This is equal to 49 by 4 minus 26 by 2, which gives us, which is equal to minus 3 by 4. This is sum of the root. Now let us find the product of the root. Product of the root will be alpha square beta square, which is equal to 13 by 2 the whole square, which is equal to 169 by 4. So sum of the root and product of the root is known to us. Therefore, the required quadratic equation is x squared minus sum of the root, that is minus 3 by 4, minus of minus 3 by 4, that gives us plus 3 by 4 x minus plus product of the root is minus 16 by 169 by 4, which is equal to 0, or it can be further simplified by taking the LCM, and then it can be written as 4x squared plus 3x plus 169 is equal to 0. Solve the given equation. The given equation is a cubic equation. It can be written as 2x cubed plus 11x squared minus 9x minus 18 is equal to 0. Whenever an equation is given, we check for sum of all the coefficients whether it is equal to 0, or check for all the odd coefficients and the even coefficients. In this question, the sum of odd coefficient is equal to sum of the even coefficient. If sum of odd coefficient is equal to the sum of even coefficient, we know that x is equal to minus 1 is the root of the given equation. Sum of odd coefficient is equal to the sum of even coefficient. Therefore, here we can say that x is equal to minus 1 is the root of the given equation. Therefore, we can write the given equation divide by x is equal to minus 1. We do it by the synthetic division method. Minus 1, write the coefficients. Coefficient of x cube is 2, coefficient of x square is 11, coefficient of x is minus 9, constant is minus 18. So here it gives us minus 2, 9, minus 9, minus 18. Minus 18 into minus 1 gives us plus 18. And so the remainder is 0. We can write the other factor as 2x cube plus 9x minus 18. Now, therefore, our given equation can be written as the given equation 2x cubed plus 11x squared minus 9x minus 18 is equal to 0. That is, it can be written as x plus 1 into 2x squared plus 9x minus 18. Now, the factors of this equation, this is equivalent to x plus 1 into 2x minus 3 into x plus 6. Equating these factors to 0, the roots of the given equation are minus 1. Equating this factor, second factor to 0, we get 3 by 2. Equating the third factor to 0, we get x is equal to minus 6. The next question, solve the equation. We see that the given equation is of odd degree reciprocal equation, that is 7x cubed minus 43x squared minus 43x plus 7 is equal to 0. So the given equation is of odd degree reciprocal equation of type 1. Therefore, we can say x is equal to minus 1 is a solution of a given equation, and therefore x plus 1 becomes a factor. If x plus 1 is a factor, divide the x squared minus 43, x is minus 43, and the constant is 7. Divide by minus 1, we get minus 7 minus 50. So here minus 50 into minus 1 plus 50 gives us plus 7, plus 7 into minus 1 gives us minus 7, 0 is the remainder. The other factor is 7x squared minus 50x plus 7. So the given equation can be rewritten as 7 x cubed minus 43x squared minus 43x minus 7 is equivalent to x plus 1 into 7x squared minus 50x plus 7. So 7 into 7 is plus 49. So the middle term can be split as minus 49x and minus z. Now this factor is equivalent to x plus 1 into 7x minus 1 into x minus 7. Equating these factors to 0, we get x is equal to minus 1, 1 by 7 and 7. So the roots of the given polynomial equation are minus 7, so minus 1, 1 by 7 and 7.